Hi everybody, Miss E here to help with more notes for physical science for basics of chemistry. Last time we talked about what atoms are, the parts of atoms, and like what charges each of those parts are, and etc. Today I'd like to talk to you about what is an element. So I have a really quick video that we can watch so that you can maybe get an idea of what an element is for yourself before I start explaining it.
Balloons are full of helium, and so is every star. Stars are mostly hydrogen, which may someday fuel your car. And elephants are mostly made of four elements. And every living thing is mostly made of four elements. Plants, bugs, birds, fish, bacteria, and men are mostly carbon, hydrogen, nitrogen, and oxygen. You and I are complicated, but we're made of
Hooray! Alright, so from our song, hopefully you can kind of tell that an element, like in the video you could see a lot of pictures of atoms, kind of like this, that they were showing, which isn't wrong. So elements are actually basically a substance made out of atoms, like a bunch of atoms of the same kind. So for example, the element carbon is a substance, that enough for us to hold, made out of just carbon atoms. Okay? Or say like a gold coin is simply a coin made out of the element gold. Everything that's in that coin is the element gold because it's only made with gold atoms. Okay? So an atom is a single piece, like a single atom or a single part of an element. Okay? An element is multiple of those atoms put together to make a substance. Okay? So, in the last section of notes, we talked about pure substances and how some pure substances are elements. So basically, like I was talking about, an element is a substance that is composed of the same type of atoms. These atoms group up to make a pure substance, okay? In total, we have 118 of these elements that we know of on Earth. So luckily, you don't have to memorize them all, and I'm not going to make you memorize any of them by heart this year. If you take chemistry in your junior or senior year, I will probably have you memorizing certain elements, but not all of them. But we do have a tool that helps us with those elements. You might have seen it on the video already. which is, hopefully you have an idea. Otherwise, I'm going to show you how those elements are organized in another video that has music attached to it. So hopefully you guys like songs. I know I do.
And
Pause. Bigger. You guys might have heard this song before. This one's fun.
now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, no gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get. Copper, zinc, and gallium, germanium, and arsenic. Selenium and bromine film while krypton helps light up your room. Rubidium and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, titanium, fermium, and nobelium, lawrencium, rutherfordium, wm, sprigium, borium, haceum, pneumatium, dubsnidium, ruthenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done. Thank you guys so much for watching. If you
Yay! Alright. So, as you can tell, the way that our elements are organized is in something called the periodic table, specifically the periodic table of elements. This table that contains all the elements is organized by mass number, and we'll learn what that is here in a second. Or maybe, actually, we already talked about it earlier. If we remember, mass number is the amount of, well, that's actually wrong, sorry. That should be atomic number and not mass number. And I'll talk about that here in a second. I'm actually going to fix that here on the fly so that there's no misunderstandings. So this is atomic number and by substance characteristics. Okay. So all of these are organized by atomic number, and if you remember the atomic number that we talked about is the amount of protons that an element has, or that an atom has in its atom, how many protons in total it has. Okay, and it's also organized by substance characteristics, and you can tell that because we have our table here that's colored. It's color coded with different colors, and there's, different different sets or like sections are different colors. Okay? So each of your squares on your periodic table has usually 4 things in it. Okay? And each piece of this information is important from top to bottom. So I'm going to use xenon as my example element going forward here. So first thing at the very top, number 54 up here, that is the atomic number of our element. This is, like I said, the number of protons that are present in the element. So xenon has 54 protons, no more, no less. Otherwise, it wouldn't be xenon. Remember, protons are what define a element or a atom of a certain element. If it had more protons, it would not be that element. If it had less, it wouldn't be. Okay. The next one down, the Xe, is called the atomic symbol. It's usually the short way that we refer to the element as. This is a universal symbol, an international symbol that we use all across our world. It doesn't matter if you're from Germany or if you're from Japan or China. Xenon is known as Xe. Okay? And I'll explain why that's important. Most of these symbols here are based off of their names. In some cases, that's not what happens though. For example, I'm going to go back here. On the periodic table, you'll notice down here, number 11 the symbol is Na. This is actually the element sodium. And the reason for that is because the original name for sodium, I believe, is natrium, and which is like, it's either the Greek or Latin name it comes from, and so that's why it's Na, because it comes from the original name that it had, and we just call it sodium in English. It might be known as natrium in where it originally came from. Same with gold. Gold is, you'll notice, number 79, the symbol is Au, because the original name of gold was Orin, and so the symbol is Au after the original name that it had. We just call it gold in English. So let's see here. Next one down, xenon is obviously the name of the element. We got to know which element we're looking at, right? Which is this one. And then, last but not least, the bottom number here is the mass number. If you remember correctly, we talked about mass number being protons and neutrons put together. For us, it's in grams and also in something called AMUs, which stands for atomic mass units, if you remember correctly from us talking about atomic weights. So this helps you along in knowing how quote unquote heavy your element is. So you can determine from this how many neutrons you have in your element. So I'm going to go through that really quick. So it says that the mass number is protons and neutrons put together. We already know, since this is xenon, it has 54 protons. And this is protons and neutrons put together. So if we take this number minus 54 from it, you're going to get the amount of neutrons that are in your element. Now you'll notice that the number itself isn't a like rounded whole number, meaning it has a decimal point on it. This is important to know that this number is actually an average of all the different types of xenon there are, because there are things called isotopes, which we'll talk about some more later, that are just different versions of an element that have fewer or more or less neutrons. It depends on the ones that we find on Earth, and we average that total mass out between all of our isotopes. So just know that when we deal with this sometimes and figuring out neutron number, we round it to the nearest whole number. So this one, if we're trying to figure out how many neutrons we would have in xenon, we'd probably take 131 and minus 54. We'll have some more practice with that tomorrow. So going back over the summary of the four things: atomic number, symbol, name, and mass. Okay. So how can this periodic table help you? So this can help you find out things like what's your heaviest elements, what's your lightest elements, and things like what's your smallest elements on your periodic table. Okay. And it can also tell you lots of other stuff too, depending on how you know how to read it. So let's see. And then again, why does the table look like that? If you notice, it's not like a typical like table or chart that normal people would make. Okay. I have it. There was an assignment post for you that goes over the history of it, but long story short, if you didn't read it, is it's made that way so, you know, with that placement, because the places where the elements are should tell you something about that element and like why it's there. So here's a quick diagram to show you how the periodic table tells you what it does. So for example, everything on the periodic table follows certain patterns, and where it's located on the table will give you a generalized idea of how much or little certain characteristics that element has. So for example, we'll notice it says not as you go up and to the right here, your non-metallic characteristics increase, or in other words, the more you go this way up and to the right, the less metallic your elements are going to be. Whereas the further down and to the left, the more metallic it is. So down here in this corner, these are the most metal of metals that you could ever have. Okay. And then we also have things like atomic radius that goes up as you go down the chart, and it goes up as you go over. We have things called electronegativity that increase as you go up and to the right, up and to the right. And then there's other things like electron gain or ionization enthalpy. Those things, those words are really, enthalpy is hard to understand, but it basically means that the likelihood of it becoming like either an ion or it gaining electrons increases as you go over and up. That's usually all it means. Okay, but these are some of the trends that we see that the periodic table tells us simply by the location of the elements and where they are. Okay, and we can talk a little bit more about that once we get to chemical bonding, which is after this unit. Okay, onward. Okay, I'm actually going to stop there because we don't want to talk about molecules quite yet. We want to just work with the periodic table and try and practice with it, determining certain things that connect to atoms as well. So for example, you will be doing some practice with looking at our period, trying to find things on our periodic table, and then looking at each individual element, trying to determine proton number, electron number, neutron number, and etc. Okay? All right. That should be it for me today. So we went through up to slide 14 today. Okay? If you have any questions, let me know. Otherwise, keep working on the assignments that I gave you, and look forward to tomorrow. Talk to you later, everybody.